Testing 1, 2, 3, 1, 2. Can you hear me okay? I think you can. And today, going to look at an original exercise that I wrote a couple of years ago called Redemption Center Empties. And this is not a Code Wars exercise. This is an exercise created by me, and it is going to be done in Python. And of course, I've got a little write-up for my exercise. But let me set the stage for y'all for this exercise. I live in Maine, and in Maine there's a hell of a lot of drunks. And in Maine we have mandatory recycling where bottles, cans, and the like, you give them to recycling centers called redemption centers, and you get a small amount of money back for bottles, cans, and such. So 5 cents, 10 cents, 15 cents, blah blah blah. So alcoholics, they're going to consume from these containers, and they will produce a lot of empty containers. So there's kind of a cycle that goes, you buy up a bunch of stuff, you drink it, you got empties, you take the empties to the redemption or recycling center, then you get your little bit of money, and then you go buy more drink. And then the cycle goes and goes, So it's just like a thing here where you got a lot of alcoholic dudes. They buy up their stuff, they drink it, take their empties to the redemption center, and then they use that money to get more stuff, more drink. All right, so there's the stage. Now, this exercise follows our friend Jimmy the alcoholic, and he's got a little dilemma that we're going to solve with code. We're going to use our coding skills, our Python coding skills, to help out the homie Jimmy to buy more beer. All right. Yeah, Jimmy the alcoholic needs more beer, but all he's got are empties. Remember, those are the empty bottles and cans and such that from his drinking. Okay. Not enough stalling, man. Okay. He will gather and count the empties, but he needs you to write a script to determine how much money he can get from them. So yeah, he needs your help. His brain is too wrapped from the drinking. He can't do this code himself. He used to code with you, but he stopped. Once you determine how much money he will get, you will then determine how many 18 packs of Bud that Jimmy can get. So he's got his stuff, and he's got his counts. Somehow he got them counted up. He's going to give you the counts, and then you're going to determine how much money he can get so he can go and buy a little bit more. The distribution of the empties will be stored in a dictionary with the following keys. The keys will be liquor, regular beer, and 22-ounce beer. So the types and the counts of those types of empties, they're going to come in a Python dictionary, and the keys are liquor, regular beer, and 22-ounce beer. The Redemption Center pays the following rates: 15 cents for liquor empties, 5 cents for regular beer, 10 cents for 22-ounce beers, and there you go. So 15, 5, and 10 for the different types. And you see up here, you remember you got the keys. So the keys are going to give you the types. Yeah, that's right. So our buddy Jimmy's going to provide the dictionary with the counts of the various empties. You're going to provide him with the total money he's going to get, along with the number of 18 packs he can buy. So, yeah, he's going to supply you with the dictionary with the types and the counts. We're going to produce a function that is going to return the total money that he's going to receive from the Redemption Center, and then the total number of 18 packs that he can buy, because the eventual reward is he's going to buy 18 packs with this. You will return a list with 2 elements. Element 0 of that list is going to be the total amount of money as a float, data type. Element 1 will be the number of 18 packs that can be purchased as an integer. And the last note, 18 packs cost $16.99. Of course, you got to know how much the 18 packs cost so you can determine how many he can get. And if you don't know, yeah, 18 packs are 18 cans of Budweiser beer. That's what I mean by 18 packs of Bud. I kind of glossed over that, but I figure most of you can kind of figure out what that is. Yeah. Alrighty. Let's look at some example inputs and outputs down here. If we have a function called redemption, and the input is this dictionary right here, dictionary at liquor 16, regular beer 180, 22 ounce 30, it's going to return 14.4 and 0. And 14.4 would be the total money he's getting from these counts. 0 is the number of 18 packs he can buy, because 14.4 is less than $16.99. So of course you can get 0 18 packs for $14.40. So no beer for Jimmy. He's asked out. Maybe he can get some 22s or something like that to tide him over. The next example, you look at these counts, 200, 587, 200, consumed quite a bit. And that returns $79.35, and he gets 4 18 packs. Next one, 123, 437, 149, returns 55, about 55.20, and he can get 3. So your input is going to be a dictionary of types and quantities, and the output is going to be a 2-element list. First element is the total amount of money you get. Second element is the number of 18 packs that Jimmy can get. All right, so I'm going to show you the code that I composed for this right now, and I'm simply going to show you the completed code because, well, doesn't matter why. I'm just going to do it. I don't need to explain myself all the damn time, right? Yeah. I'll do it full screen first. So to recap, we're getting a dictionary with the keys will be the type of empty. The value will be the quantity of those empties. We got to total them all up, and we got to determine how much money we're going to get for each and total that up. So looking at the function that I composed, empties will be the dictionary that comes in. Total money is, of course, it's a float variable that's going to hold the total amount of money that we're going to get from totaling up the cash from the empties. I do a for loop, and I'm looping through the dictionary. Empties is the dictionary. This is a for each loop where I'm looping through the dictionary empties. And types will be a key in this case. And if the key equals liquor, I'm going to add the value, because empties index types is the value times 0.15. Remember I said 15 cents for liquor empties. So let's zoom down here real quick and look at this key value pair. Liquor, the key, value 123. When I index in here with types into empties, on this first, for this condition, I'm going to get a 123. 123 times 0.15 will give me 123 at 15 cents each. and I'll get some kind of I don't know what the answer is, but I'll get that answer. That answer is going to be added to total money, and there we go. 123 times 15, 15 cents per. That's how the totaling up is going to be done. You index in using the key, you get the value. The value is going to be the count of the empty. You do the empty times the amount of money you get from the redemption center. There we go. And so we have an elif, and actually this if is not correct. This should be another elif, actually. Let me correct that one real quick. Yeah, sometimes you find little mistakes in your code. I don't know why that's like that. Because this is exclusive. We're only doing one type per iteration. There's only going to be one key per iteration. So yeah. So yeah, regular beer will be times 5 cents, 22 ounce times 10 cents. And yeah, good to go. So as you continue your iterations, you're going to get through all of these keys, and you do the totaling up. And so once the loop is done, I'm going to have my total money all calculated, and it'll be in a float. The next piece is how many 18 packs can Jimmy buy? Well, when you have a total, if you want to determine how many of a certain thing can be bought, you would take that total and divide it by the cost of said thing. So on line 12, I create a variable called packs 18, and I take my total money divided by $16.99. $16.99 is the cost of an 18 pack. So taking my total money divided by the cost of the 18 pack will give me the total number of 18 packs that can be bought. And it'll be stored in packs 18. And what I do is I take that the result of the division, and I convert it to an integer, because you can't buy part of an 18 pack. So I want a whole number generated from this. So if it's like 3.3, I cannot buy 0.3 of an 18 pack. I can only buy 3 total. So you just, yeah, I've explained enough. Line 14, I return a list, and I return a list in this format. Index 0 is the total money that I generate from all the bottles and cans. Index 1 is going to be the number of 18 packs gotten on line 12. There it is, kiddos. And let me take some sample runs of this mother trucker. Okay. You thought I was going to say something else, didn't you? Alright, so we got 2 dictionaries here, and I'm already set up to run the August dictionary. So and I believe both of these are correspond to the examples that I've already set up. So let's take a look over here. Let's contract this. Yeah, the August one, this August dictionary, I believe corresponds to this one right here. Okay. So I should get 555.19 and 3 when I run this one right here. So let me go ahead and run that. These results are time tested over years of study in the lab. Hit that run. Okay, we see 55, 20, and 3. Yep, got that. This other one, this January, will correspond to this result right here. So it should return 79, 35, and 4. Clear it out, clear it out. All right. So to run that, of course, I've got to replace. Let's hit that run. All right. We see 79, 35, and 4. All right. So we got a good situation here. It works. And of course it works, because, yeah, I don't need to explain that. All right. So here we are with Redemption Center Empties, and we've cracked the code. We found how we can get we can calculate the cost of Jimmy's empties and be able to get him a result of how much money he's going to get and the number of 18 packs he can buy, so he can be on his way. We can help out our friend, and we can be a good buddy. And we did a little bit of code. So this is a win-win situation where you help out a friend and you can practice your Python skills. All right, folks, this is it. Redemption Center Empties, an original exercise from me. And yeah, my name is Dean, but that don't matter. What matters is you saw some cool code, and that is it for me. And I am out.